All right, in this video, I'm going to take you through section 2.5 of the AP Chemistry textbook, which is all about the basics of the periodic table. So I know all of you are going into this with a little bit of knowledge about the periodic table. You probably know the basics of how to read it, but the periodic table is the most important tool that you have in chem. It's going to help you in every single unit with every problem that you do. So it's just super important to have a really strong understanding of everything on it. So we're going to start with the basics of how to read the periodic table. So when we're looking at the rows on the table, those are called your periods. These aren't super important. They're not really discussed much. What we talk about more importantly is the groups, which are the columns on the table, because these are the categories of elements that share similar chemical properties. And this becomes really important as we get further into the curriculum. So the elements on the periodic table are arranged in order of increasing atomic number, which is, of course, the number of protons in the nucleus of the element. And then when you're looking at the table as a whole, there are these little steps we'll see in a minute that divide the metals and the nonmetals of the table, and the elements in the middle are called the transition metals in that center block. So we'll see that in a moment. But now I'm going to talk about how to look at one element on the table. So in this example, we'll use oxygen. So in the middle, of course, the letter is the atomic symbol. And over the symbol, we have the atomic number. So that is, as I said before, the protons. And then at the bottom, we have the atomic mass below the symbol. So remember that atomic mass is calculated using the number of protons and the number of neutrons, because all of the mass of an atom is found inside the nucleus. So the mass here for oxygen is 16. So here's a full view of the periodic table. You'll see everything is red in the metals. That everything in red is the metals. That makes up the majority of the table, especially that middle block that's lower than everything else there. Those are your transition metals. They all share very, very similar chemical properties. And then you'll see the bold staircase over on the right side of the table, and those yellow elements, which are your metalloids, which I'll talk about a little bit more later. Those are your elements between metals and nonmetals, which is the blue, your nonmetals, where you'll see more gases and liquids and some more differing chemical properties. So now we'll move on to talking a little bit more about groups. So a lot of the groups have special names that we use to identify them. In this example, I'll talk about group 1A, which is furthest to the left, that leftmost column on the table. Those are your alkali metals. Then right next to them, group 2A is your alkaline earth metals. And then when you jump over to the other side of the table, you have group 7A, which are your halogens, and group 8A, the noble gases. So all of these groups share some important characteristics. I'm not going to go into that right now, but for example, your alkali metals and halogens are the most reactive elements in the table, because in group 1A, they just have one electron that they need to lose, and in 7A, they just need to gain one to have a full shell. And then your noble gases are the least reactive elements in the table because they have a full valence shell of electrons, so they're not eager to react with anything else. So what I said before about groups 1A and 2A and all of that is based on how we name the periodic groups. So there are three main ways that these groups are identified. We rely mostly on the American way in chem. That's pretty much the only way that you'll see it. But just know when you see multiple labels over the groups, those are referring to these. So the American way uses A's and B's. So all of the B columns are in that transition metal section. Those aren't super important. We don't really ever refer to those metals using their groups. But the columns on the left and the right side, we use 1A and 2A over on that left-hand side, and then you jump over the transition metals to 3A through 8A for the rest of those columns. The European method is very similar to the American, but I'm not even going to talk about that because you're never going to really see it. And then the IUPAC method of labeling is just sort of a standard, but we also don't really use this. It's just labeling all of the columns 1 through 18. So talking about categorizing elements, we'll go into another main way of doing so, which is your metals, nonmetals, and metalloids, like we saw earlier. So metals, if you recall, make up the majority of the elements on the table, and they all share some important properties. Metals are lustrous, they have high heat and electrical conductivity, and all but one metal is solid at room temperature. Bonus points if you can remember what that was. It's mercury. It is a liquid at room temperature. And then we have our nonmetals, which are much more variable in their properties than metals. They tend to differ in appearance, and while most of them are like not lustrous, not conductive, other than being different from metals, they don't have a lot that we can like strictly say is in common between all of them. They can be gases, they can be liquids, they can be solids at room temperature. Again, there's a lot of variety between them. And then you have your metalloids, which is a very small category right in the middle there, that share some properties between metals and nonmetals. So now I'm going to take you through just 3 practice questions to make sure that you have a solid understanding of just how to read the periodic table and how to identify some elements. So first, I want you to find period 5, group 7A, and identify the atomic mass of that element. So when you're going through this, you should be starting with the rows of the table and going down to the 5th row, which starts with rubidium. And then to find group 7A, you're moving over to the second to last column, which should start with fluorine and going down from there. And where they match, you should be on iodine. And then reading the atomic mass, which is the number below the element. So your answer for this should be 126.9 AMU. For the next question, we're going to look at the element OS and identify whether it's a metal, nonmetal, or metalloid. So honestly, the hardest thing about this is finding where that element is. It's just one of those things that you have to get used to. You do a lot of searching, but you should identify this element once you have it as a metal because it is in the transition block of the periodic table. So that one is an easy one. And for the last question, you're going to find the atomic mass of NaCl. So the way that you need to do this is to identify both sodium and chloride on the periodic table, and then find the atomic mass for both of them and combine them to get the atomic mass of the molecule, because you only have one atom of sodium and one atom of chloride in a sodium chloride solution or mixture. So once you do this, your answer should be 58.44 AMU. So that's all I have for you on this today. So all I can say is good luck with the rest of this class.